So the final thing we're going to look at is a word problem. And one of the applications of logarithms is sound, actually, or the Richter scale, or things like that multiply by a big amount really fast, right? And so intensity of sound is actually measured in decibels. So you've probably heard decibels before. And it's modeled by this equation right here, which is D times W, where W is some intensity of sound, is equal to 10 log of W over W0, where W0 is some constant value. In fact, it's this one, 1 times 10 to the negative 12 watts per square meter. So it says if the intensity of sound of a person talking loudly is 3.16 times 10 to the negative 8 watts per square meter, what is the intensity of sound in decibels? So we're just looking at basically what is D? Okay, well, D is going to be, well, our equation was 10 log of W, which they just told us W is 3.16 times 10 to the negative 8, over our constant, which we were given, 1.0 times 10 to the negative 12. So this is actually just a number, and we can put this into our calculator, right? Because the nice thing is, check it out, log is common log, so we can use it on our calculator. And we do 10 log, and then in parentheses, I'm going to do 3.16 times 10 to the negative 8 divided by 1.0 times 10 to the negative 12. And when I do that on my calculator, I end up getting 44.996. So I'm actually just going to round that to 45. So what is the intensity level of sound? It'd be intensity level of 45, I guess it'd be decibels. Is what it, okay? And so they used to always say that, like, the Metrodome or something like that, when it was rocking during Vikings games and stuff like that, was like 100 to 105 decibels. So it'd be about twice as loud as that, right? And it gets pretty loud in there, right? All right, so let's look at another one. Now, let's say if the threshold of hearing for a certain person with hearing loss is 5 decibels, so very small, will a sound with intensity of 2.1 times 10 to the negative 5 watts per square meter be audible to that person? So basically it's saying if we have some decibel level of 5, if D is equal to 5, is someone who has a sound at 2.1 times 10 to the negative 12 sound going to be greater than 5, right? Are they going to be able to hear it, right? That's really what we're looking for. So let's take a shot at this. So we said that D was equal to 10 log of W, which in our case is 2.1 times 10 to the negative 12, over that constant, which is 1.0 times 10 to the negative 12. Okay, so let's do that on our calculator, and we'll see what we get. So 10 log of 2.1 times 10 to the negative 12 divided by 1.0 times 10 to the negative 12. And when I do that, I get this value of D to be 3.22. So is 5 smaller than 3.22? And the answer is no. So a sound at this level right here, 2.1, would not be audible to someone who with hearing loss. Okay. All right, finally, the last one, they tell us actually our sound is 85 decibels. And so we need to figure out basically what the sound is going to be. So we'd set it up like this. We'd say 85 is equal to 10 log of W, which we don't know, over 1.0 times 10 to the negative 12th power. Okay. So how would we solve this? Well, if I'm looking at this problem right here, okay, and I wanted to solve it, first off, I would say, okay, well, I have to get rid of this 10 right here. So I'm going to divide both numbers by 10, okay? And so then I get 8.5 is equal to log base 10 of W times 1.0 times 10 to the negative 12, okay? Now, before we can go any further to answer this question, we have to know properties of logarithms. And that's actually what we're going to talk about in the next section. So we're going to stop this problem here and we'll finish it the next time. Okay?